Hi, everyone. Welcome to this next edition of the Movements and Rhythms of the Heavens. Last time, we talked about the motion of the sun across the sky, and today we'll be talking about the motion of the stars across the sky. But to help us out with that, we actually should just briefly review what we learned last time, thinking about the motion of the sun across the sky. So we're going to take a look at that by using a program here called Stellarium. We used this last time, so we're going to bring that up into view here. And so you can see there's the sun across the sky. We're going to let it go into motion. We talked about this last time. Of course, as the sun starts moving, you know it's not the sun that's moving, it's the Earth that's spinning underneath it. That's actually a key idea in terms of motion in the sky. First of all, it is the most prominent motion that we notice. Obviously, it takes place once every 24 hours. So any objects that we're looking at in the sky are also going to move fairly rapidly because we are doing the spinning. The other consideration, though, is that as we spin, it's not just the sun that we see go across the sky. Now that you can see the darkness arrive, you can see the stars are going across the sky as well. And so that fits into what we'll be talking about today, the motion of those stars. Now, thinking about the motion of the Earth just for a moment, we're going to use another program just to quickly illustrate what we were thinking about before, and that's the motion that we saw just because the Earth is spinning. The Earth, of course, spins on its axis once every 24 hours, and one of the things you can see in this particular image is you can see the Earth's axis is not straight up and down. If you can sort of notice the motion here, kind of think about where it's stationary. The North Pole is right about where that cursor is here. And so as the Earth is spinning, we're tilted on a little bit of an angle. This creates some changes that we see in terms of the sun in the sky. Again, we talked about that last time. And so again, a good way to see that is to use some illustrations here. So we're going to just need to switch programs here for a moment. And so we're now going to take a look at the motions as we can draw them out. And so we'll start here thinking about the sun. And so there's the sun in the sky. It is, of course, our nearest star. So I suppose if we're talking about the motion of stars in the sky, you could include that. But in particular, we talked about the motion of the sun and keeping track of it. If you remember your project from last week, and this is something that's an ongoing project because it'll take nearly a year to watch where the sun sets along the horizon. But these paths that you can see illustrated here give you that opportunity to perhaps see this happen. And so we end up with the motion of the sun, say close to today, or here we are, after the equinox, but the equinox about March 20th or 21st, the sun rises in the east, gets up to about halfway up in the sky, and then sets exactly in the west. As we go through the next few months, you'll be observing the sun climbing higher into the sky and shifting more to the north. So its rising point is north of east, and its setting point is well north of west. As we go through the second part of summer and then into the fall, the sun first gets to its equinox position on September 21st, and then continues over into the south. Now, these are all motions that have to do with the sun. So why am I pointing this out in such detail? Well, it turns out that this motion also is a great illustration of what happens in the terms of the stars. So let's think about that for a moment. We'll again use the program Stellarium to kind of help us get a sense of that a little bit here. And so if we go back to the daytime sky, which means we're going to reverse time here. So we're going to go back a few hours. And let's do that right here. Going back a few hours until the sun is up in the sky. There you can see the sun. Now, the reason I wanted to put the sun up in the sky specifically was that by seeing the sun in the sky, of course, we don't see any other stars. However, I can make an adjustment on the program, and that changes what you see in the sky. Now, you can see the sun in the sky, but look at all the stars. Why do I mention that? It's because you can now think about the sky in motion, that the stars, depending on where they are in the sky, are going to track differently. And so that's one of the key things to think about in terms of the motion of the stars in the sky is where do we see them and how does that change what we see in terms of their motion. So thinking about that, we'll go back to the demonstration here and we'll take a look at our slides once again. And so let's come over to here. So the image that we left with, seeing the motion of the sun, of course, depending on where the star is on this same sort of field, it would rise toward the south, it could rise in the north. It will make a difference in terms of the path that you would see in the sky. Notice that the path of the sun, for example, when it's in the south, is a fairly short path. It doesn't climb very high up into the sky, rising in the southeast and setting to the south of west. On the other hand, the path of the sun on June 21st, the first day of summer, starts in the northeast. It climbs very high up into the sky and then sets way up to the north of west. And so these differences that you're seeing here would be differences that you would see in terms of the motion of a star in the sky. The other thing to consider is, of course, the motion that we're seeing, the angle that you're seeing has a lot to do with the Earth in its orbit around the sun and the angle of the Earth's axis. You can see in this picture, the North Pole of the Earth is angled to the right in the image, and this angle doesn't change. It's about 23.5 degrees. You can see that number kind of in the middle of the page there. The angle of the Earth doesn't change, but our position changes relative to the sun. So it changes where we see the sun in the sky. Now that would be true of the sun because it's inside the Earth's orbit. Obviously, we're orbiting around the sun. The stars, on the other hand, are outside that circle, and they're far, far outside that circle. As a result, the stars don't really change in terms of their motion during the course of the night, unlike the sun, which of course changes not so much in a single day, but it does change over a period of time. So that's one of the things that we'll be talking about in terms of motion of the stars is how they change not just during a single night, but also how they change over an extended period of time. So thinking about the sun here just briefly once again, here's an example of the sun rising, and this is a series of images taken from Iowa. Iowa's a nice flat place and a good place to see the horizon. And so here's the sun rising on the summer solstice. You can see a couple of silos in the middle of that picture. So as the sun rises on the solstice, you can see it climbing up a little bit of an angle. Now, what's going on here is the Earth is angled toward the sun. The North Pole portion of the Earth is angled toward the sun on the first day of summer. It shifts the sun higher or more northerly in the sky, and that's where you can see it rising. By the time we get to the equinox, the sun will be rising due east, and it happens to be right between those two silos. And again, you can see the angle of the Earth rising. And finally, we come to the first day of winter. The sun will be rising well to the right of those silos, so you can see it changes quite a bit along its horizon. Hopefully your project, you'll start noticing that over a period of time. But in this case, we're looking at the position where the sun is on the first day of winter. The North Pole hasn't changed its angle, but it is angled away from the sun in terms of the Earth's orbit. So that keeps the North Pole completely in the darkness. There are no sun rising right on through the 6-month period at the North Pole. And the Arctic Circle is actually the area in which the sun stays below the horizon continuously for at least one day. So the Northern Pole, no sunlight. That's why it's a source of cold air during the course of the winter. Now, with the Earth rotating or orbiting rather around the sun, the other consideration, thinking about the North Pole and now thinking about stars, is that the North Star is always above the Earth's North Pole. Now, in this image, you can see 3 different stars, obviously, depending on where the Earth is. This is very misleading, but it was kind of the only way to draw this. No matter where the Earth is in its orbit, it is always angled so that the North Pole is angled toward the North Star. Now, why are there three stars there then? That's because the North Star is extremely far away. In terms of distance, it is 200 light years. Now, a light year is 6 trillion miles. So that amounts to over a quadrillion miles away. It is so far away that no matter where the Earth is in its orbit, the North Star is always in the same place. Even the stars that are closer to us, they are so far away that the stars don't change position in terms of shifting north and south in the sky. The stars are very consistent that way, always seen in the same place at the same time of night or the same time of year. But the North Star is unique. It's exactly above the Earth's North Pole. So as the Earth goes around the sun, the North Star remains always in the same place. And think about it. If the Earth is spinning around, that means that the star that's right above the North Celestial Pole never moves. So the North Star, Polaris by name, that never changes its position in the sky. Now, the other thing in this illustration is we've got you pictured as kind of standing on top of the Earth, but that would change your view depending on where you are on the globe. And so we've added to this illustration a line that represents your horizon. Now, for us, in the northern part of the globe, north of the equator, we can see the North Celestial Pole, or you can see where it's located in the skies, and so that's where the North Star would be located. So it's always in our skies, daytime and nighttime. Obviously, we just don't see it during the day. If you were to change your position on the Earth, it would change your horizon, which would change where the North Star would be located. It would also change where you would see the stars. So if we add this new circle into the same image we saw before, this bright yellow circle on the right, all the stars that are inside that circle remain above the horizon and they circle around the North Star. So this is one of the key things in terms of thinking about motion in the sky with the stars, is that there are some stars in the north that never leave the sky. If you look toward the south on the left-hand side, there are stars that only briefly come up into the sky. In fact, if you imagine the stars completely around on this celestial sphere, there would be some stars that never appear, not at least in our skies. Another way of imagining this is to watch the stars over a period of time. We're going to do that with our Stellarium program in just a moment, but these are some great sort of photographic illustrations of what you can see in the sky. So here we have a circular pattern of stars. Can you imagine why that would appear this way? Obviously, you've never seen the stars look like this. This is an image taken by a camera, what we call an extended or long exposure. And what happens is, if you leave the camera lens open so the light is continuously coming into the camera, then over a period of time, the star moves. And that motion is captured by the camera. In the middle of that motion, there's a star that makes a very, very tiny circle. Yes, that's the North Star. The North Star isn't absolutely perfectly lined up with the Earth's North Pole, and so it makes a very tiny circle. Essentially, it stays in the same place, and all of the other stars move around it. Now, this is a view looking in the north. If we take this same view and look toward the south, we now see stars arcing across the sky as you would see it in the southern part of the sky. And if you notice toward the bottom, the star paths are very short and very low above the horizon. This is the case of stars that we see in the south. They never climb very high into the sky, and they take a fairly short trip. They're only out for a relatively short period of time. Finally, if we were to look toward the west, you can see the paths of the stars. But in this case, they're taking an angle toward the horizon. Now, this is kind of interesting. Instead of setting straight up and down, they are setting on a bit of an angle. That angle is actually the Earth's equator projected out into space. So in other words, you're on the northern part of the globe and the Earth is tilted. It creates a change in the path that you would see the stars take. Now, these are some nice still images, But a better way to see this, or at least a different way to see this, is to put the stars into action. So we're going to do that now, switching back to our program called Stellarium, and we'll put that back in the screen here. And so there you see our program Stellarium. And we have a daytime sky. You remember, we mentioned that the stars are out even in the daytime. We just don't happen to see them. So if we bring the daytime sky back in, there it is, the way you would imagine it. So we're going to let the sun head across the sky here. We'll speed up time. And there goes the sun heading toward the west. In fact, we can go much faster if you want to, in terms of thinking about if you have this program on your computer, you can try this out. But here's the evening settling in. You can see the stars appearing. But we're going to change our view. We're looking in the south right now, and I want to start by looking in the northern part of the sky. So we're swinging around here into the north, and somewhere in the north is the North Star. Can you tell which star is the North Star? It may not be easy just by simply looking at the stars that are out there. So one thing that would help is to actually set the stars into motion. So instead of watching this over, say, a few hours, you can speed up time with this particular program, and we can actually watch and see if you can figure out which star is the North Star. So I'm going to set things in motion here, and you can see the stars moving now. As they're moving, there is one star, I think, that stands out. It's something unique. Are you noticing something in the north? There is one star that isn't moving. It's the North Star, and that's why it's the North Star. It's the star that's right above the Earth's north axis. That's obviously not spinning around, it's spinning in place. That's the pivot point. So that star stays in place, Polaris, the North Star, and all the other stars appear to rotate around it. So there are stars in the north, but they're making a circle around the North Star. So let's stop that motion for a moment, and let's now look at the same idea, but let's look in the southern part of the sky. And as we look over toward the south, I kind of snuck something in on you. This is the daytime sky. You can actually see this is the sun right here, but we're not focused on the sun. We want to watch the path of the other stars, the nighttime stars, in terms of their motion in the sky. So we're going to set them into motion again here. And so pick a bright star like this bright star Fomalhaut down here in the south. Notice that the stars in the south, they're only up for a brief period of time. They don't get up very high above the horizon, and then they quickly set. So the motion in the south, very different than the motion of the stars in the north. Finally, if we look toward the west, and of course you can see the sun there, but you can see all the other stars. And if we set them into motion once more, notice that they're not setting straight down, they are setting on an angle. Now, if we blend this all in fact, if we shift our view from the west toward the north, it's all the same motion, but it has to do with the Earth spinning on its axis, and this changes the position of the stars. And this suggests an activity, something that you can try out in terms of observations. So we're going to stop the motion here, and I'm just going to briefly outline a couple of ideas about what you can look for in the skies. So this is a project for you to observe the motion of the stars. So one of the first things we can do, and we'll post this on our website as well, but for right now, I'm just going to swing around our view into the south. And as we look in the south, here's one of your objectives. There'll be 4 different things that you can try out. So the first thing is to look in the south for a moderately bright star. It doesn't have to be exceptionally bright. In fact, if we go back to an evening view during late April, this is not the evening, this is actually a little bit later at night. So let's just shift our view just a little bit here so we can see what you might see in the evening sky. There are any number of stars over here in the south, and what you'll want to do is pick one and make sure that it's one that you can identify. Just because of brightness, this star Spike is actually brighter than many of them that are over here. And so you could watch that, for example. Watch it over the period of time of an hour or two. Notice where it is above the horizon, notice how it changes, and notice where it's going. Now you can do the same thing, but change your view into the north. And so if we swing our view into the north, again, you can pick any moderately bright star somewhere here in the north and watch it over a few hours. One other possibility, and this is especially true for the northern sky, because you perhaps could get up in the middle of the night, maybe you'll wake up randomly in the middle of the night, but maybe you can set an alarm clock for 2 or 3 o'clock in the morning. The idea would be to observe where you would see the Big Dipper in the evening, and then notice where it is several hours later. By making note of where it is when you start out and what time it is and where you see it later on, you'll start to get a sense of its motion. But you can do that with any group of stars in the north. All you have to do is just pick a star that you can see that's fairly bright and watch it over a period of time. Now, another possibility is you can look to the west. Now, in this case, when you look to the west, there are a number of stars over in the west, so that makes it easy to pick out a star, any moderately bright star that's over there. But as you look over there, watch what it does over a period of 15 minutes to 2 hours. So it doesn't have to look for a long period of time, but you can watch, notice where it is above the horizon, and then watch over time, keeping track of time, and see where it is at a later point. You can see, you can do this with the program, the star setting, but just how quickly does that happen? And that's something, again, you can make note of. Another possibility, and our fourth sort of aspect of our project here, you can look to the east, look for stars that are coming up. You pick a star that's just edging above the horizon. There's a star just to the right of east. And if you watch it climb up into the sky, what do you notice? What path does it take? How quickly does it move up into the sky? So these are all things that you can observe, and it will give you a much better idea of this motion of the stars in the sky. Now, the idea of these motions that you see with the stars, of course, are talking about the stars moving during the course of a night. We have another possibility. If we think about the sun moving, or the stars moving not just during the night, but over a longer period of time. So let's go back to our slide program here for just a moment. So the Earth, of course, is going around the sun. But because we go around the sun, and because the stars are so far away, where we see the sun relative to the stars and where we see the stars during the nighttime is going to change depending on what time of year it is. So this is another consideration and something that actually involves a longer period of observation, not something that you can see in a single night. This is something that you're going to have to observe over a period of months. And so we're going to do that next time. We're going to talk about the motion of the skies over a longer period of time. Got a few kind of nice pictures here of Stonehenge over in England, where they've been watching the skies for thousands of years. But our project is going to be to watch the sky, not just during a night-to-night idea or during the course of the night, but over a period of weeks, months, even the entire year. And so that's going to be our next observing project, but we'll do that on the next sort of edition of these movements and rhythms of the heavens. Thanks for joining us.